Hi everyone, we are come from Group 3. These are the group members.
In Part A, the basic financial assets, interest rate, and the modeling of dynamic asset price will be discussed. There are also two examples of model will be used to simulate the future price. Generally, financial assets can be classified to risk-free assets and risky assets. For example, bond will have amount of a return that guaranteed, but for the stock price and derivative will depend on the uncertainty of stock market. Interest rate is amount of money that a lender charges to their borrower and is in percentage. The interest rate and the principal value will affect the amount of money that need involved in paying to lender or received from borrower. The stochastic process of the trend of the stock price cause it include the uncertainty. This problem caused the investment of the stock price by investor become challenging. Therefore, the dynamic model is used to handle the complexity. The two models used in this assignment is threshold model and geometry Boolean motion (GBM). Example 1 is using threshold model for modeling the call option. The situation is finding the price of an Arabia stock option expired in 6 months with a exercise or stick price $40. Assume that the underlying stock plan not evident strength at $42 and have a volatility of 20% per annual. The risk-free range is 1% per annum. For the example 2 is using GBM model to simulate the asset price. The situation is use the GBM in simulating the stock price of Alibaba Company Limited. They are the information used. For the situation 1, the call and put options are calculated and equal to 4.7594 and 0.8086 respectively. For the situation 2, the graph shows a large difference in plans due to Boolean motion. The similarity of both graphs of the expected price plans are those that show increasing from 2018 to 2043. Besides that, the graph show a strong volatility for their range of their return.
At first, Monte Carlo can be said that it is highly competitive with the deterministic quadrature, but it is a better method when computing a multidimensional integral. There are two types of option, which are call option and put option. Call option is a contract where the buyer has the right to purchase the underlying asset at a specific price, also known as a strike price, within stipulated expiration date. Put option is a contract where the buyer has the right to sell the underlying asset at a strike price by a specific time. Both call and put option consist of long and short positions, which are used to purchase the option and sell the option respectively. The journal article that we choose is Option Pricing Using Monte Carlo. If you want to obtain the profit in investment, there is a need for processing a proper evaluation. However, the asset valuation of option is quite difficult and hard to accomplish. Therefore, the research proposed that utilize the Monte Carlo simulations method to forecast the price of plain vanilla options and to compare them with real option price and option price calculated using analytical Black-Scholes formula. In methodology, the historical data used is S&P 500 index of the period of 2011. S&P 500 index options are divided into call and put options. There are four equations that illustrate long and short position in call and put options respectively. Besides, MATLAB software is also used by the researchers to adopt Monte Carlo simulation in option pricing. First step is to choose and specify the option and data needed. Then, calculate the time increment using calendar time. Next, the researchers generate the future asset path. Fourth step is calculating the payoff for each path for both call and put option. Last, the option price was reached. This equation is used to compare price adequate with Monte Carlo simulations with the price calculated using Black-Scholes model. First one is the price for call option and then price of put option. And the third and fourth equation is the probabilities factor.
For your information, S&P 500 index asset path were generated into three period groups, namely weekly, monthly, and 50 days, which are taken from the year of 2011. The first figure illustrates the asset path of weekly period, and because of the similar in every weekly period, so asset path of January is taken. Same goes to the monthly and 50 days period asset path. They all have the same view. By using the equations of this option that stated before, the simulated weekly European call and put options are generated. The monthly and 50 days period of European call option and put options are also generated by using the equations. In this slide, these two graphs show that the simulated and real data in weekly period for put and call options. From the graph, it can be seen that most of the cases of simulated call and put options vary only in tenths, but some of them do not match at all. This is because there are some value missing in the real data. However, it can be concluded that Monte Carlo simulation works well in weekly period simulation. For the monthly period, there is not much difference between the simulated and observed options prices, and it shows the perfectly match between them. It can be said that in monthly period prediction, Monte Carlo simulation helps very well. Last, for the 50 days periods, the graph also shows the similar result, and it also can be concluded that Monte Carlo simulation works very well in a longer period of time. Next, another objective that carried out in this research is to compare the simulated prices with the auction prices calculated using the analytical Black-Scholes formula. The prices calculated by Black-Scholes formula use the same data from S&P 500 index from year 2011. In these two graphs, it is shown that the weekly simulated call option prices are a little bit higher than the Black-Scholes call option prices, whereas the simulated put option prices are a little bit lower than Black-Scholes put option prices. Next, for monthly period data, the simulated option prices and Black-Scholes options prices are almost matched in the beginning of the year. While for the 50 days data, simulated and Black-Scholes option prices move together. However, Black-Scholes call option prices are higher than the simulated prices, whereas Black-Scholes put option prices are lower than the simulated put option prices. From the result, we can see that Monte Carlo simulation is a good method to predict option prices, and it can be used either for very short time periods or for longer time periods. In a short period, both Monte Carlo and simulation and Black-Scholes formula work well in predicting option prices. However, when the periods increases and the amount of data increases, there are some errors in the Black-Scholes formula, but Monte Carlo simulation is able to give quite accurate results for the medium and longer periods.
That's all for our presentation. Thank you.